Hello everybody, I'm Professor Charlie Collins, and today we are going to do an Excel workshop on regression and conducting a regression analysis in Excel. You can do multiple regression in Excel. I would recommend using more complex statistical packages for more of your complex analyses, your regression analyses. So today we're going to run a linear regression with some data that we have here. And so these data were collected from a couple of different websites. One was collected from a university's website, and as well as Rate My Professors and the state of Washington's salary website. So you can look up any public university or public official, anybody who's paid by the state, and look up their salary for the previous year. And so we have four different variables here. We have school, right? So which school is this particular professor in, their rank, so assistant professor, associate professor, full professor, and then we also have part-time and senior lecturers in here as well. And then we have the data from Rate My Professor. And so this is linked to each professor. And so students looked up their Rate My Professor quality. So there's a quality indicator, how students have rated professors' quality on Rate My Professor. And then from the state of Washington's website, we got their last year's salary. And so what we can do in a regression analysis, so typically what you want in a regression is two interval or ratio types of variables. It's not always true. You can get into more complex analyses with non-continuous data, categorical data, but for the purposes of this, we're going to use interval and ratio data. And so specifically, we're going to look at the Rate My Professor's quality, ratings, and salary to run our analyses. So we could start off with the research question. Is there a relationship between Rate My Professor's overall quality measure and faculty salary? And so our null hypothesis would be something like overall quality and salary is not related. And our research hypothesis might be something like overall quality ratings go up, so does their salary. So note this is a directional hypothesis. All right. And so the way we want to run our regression analysis is we want to go to data, and you want to make sure your data analysis tool pack is up. And if you don't know how to download that, there's other videos that can show you that. So we click on our data analysis tool pack. We go down to regression, which is sort of middle bottom in our various selections and our options here. And so click on regression, and you want to click OK. For your Y input range, I like to minimize the box here, and I will just select all of the data in salary. So drag all the way down. Okay. So D1 through D64, and then for the X input, we'll do the same thing, but in the C column. Okay. So we have our data there. We have our 63 different values. We want to make sure labels is selected, and then we want to do a new worksheet. And I'll call my worksheet regression. You can call yours whatever you'd like. And residuals, standard residuals, residual plots, line fits. You can do this if you'd like. It shows you the residuals. It's not necessary for this. So we're going to click OK. So let's open up our output here, and let's go through each of the different components. So in your NOVA box, this tells you the significance of the overall model. So it tells you whether or not the model itself is significant. And then this tells you the values, the significance of each individual variable. And so this is helpful, particularly when you're doing a multiple regression, when you have multiple independent variables. Both are informative. And then this tells you specifically each independent variables and the relationship between each independent variable and the dependent variable. And so we have our dependent variable is salary, right? And so we're interested in the question, is there a relationship between rate my professor's quality and salary? So I'm going to go straight to this box here, and the data that I'm going to look at specifically is the p-value, so I'll highlight that. That's usually the first place I go. And then the coefficients, right? And so what we see here, unfortunately, is that, or I guess this is probably unfortunate, is that there is no relationship between rate my professor's quality and salary. So our research hypothesis was not accepted, our null hypothesis was accepted. And so let me just go through several of these components here. So this highlighted yellow, the coefficient, I'll highlight this blue actually. So the blue highlight here is our slope. All right, so remember when we're running our equation of y equals bx plus a, this is going to be our b, right? So b equals slope, and then a equals intercept. The intercept is right above it, and so I will highlight this green, right? And so the intercept is green, the slope is blue, and then this yellow highlight tells us if there's a significant relationship between them, or between the two variables, between the dependent and independent variable. So in this case, there's not, so our null hypothesis is accepted, and our research hypothesis is rejected. There is no relationship here. All right, well, thanks for watching.